Hello everyone, welcome to my channel. So today we are going to do Leetcode line simplify list question 3 sub. So in this question, let us first read this question, then about the constraint, then finally write an upon the example, and then going ahead with the coding part for the same, and also time complexity and space complexity. So let us first start with the checking out that what exactly question want us to do. So that's the thing. So now here, a minute. Okay. So given an integer array num, return all triplets, nums of I, nums of j, nums of k, such that I is not equals to I is not equal to k, and j is not equal to k. Means basically no duplicates are there, and nums of I, j, and k equal to 0. Means basically we are required to figure out with three numbers, and adding up all these three numbers should help us with the total sum as 0. So that's the thing here. Now notice that a solution set must not contain duplicate triplets. So that's also one of the things. Now let us go ahead with the constraints which are being given to us. So constraint says that the length of the nums would be minimum 3 and maximum 3000. So basically, we are not required to check for the edge case that if three numbers are not present there or not. That's the thing. And here numbers would be present negative as well and positive as well. That's why, and that's how we will be able to figure out with the sum equal to 0. So now let us go ahead that how we can do this question. So here one condition was there that I not equal to j I not equal to k, and j not equal to k. So basically all the indices should be different, and even when we add them up, it should be equal to 0 and no duplicate should be there. So according to that, we are required to do things here. So here, if we choose -1, then 0, and then 1. So this is one of the triplet which will be having sum equal to 0. Now, if we choose, uh, if we choose here 1, 2 and -1, then sum would be equal to 2. If we choose 2, -1 and -4, right, then the sum would be equal to 2 minus 1, 1, 1 minus 4, -3. So this won't be any triplet, right? But if we choose this -1 and this -1 and this 2, then the sum will be equal to 0. So like this, there would be various instances where in actual we are required to figure out that any integer value in this particular input where we can easily add up to 0, and that we are required to figure out means it is not necessary that they would be all together. They could be scattered if this whole nums array. That is the thing here. So that's why we are just required to check that at which point and adding up which all would be equal to 0. So and we also need to check that there are no duplicates, triplets which are there. Means if we are having this -1, 2, right? So we are not storing something like this again because there could be possibility numbers could repeat, right? So that's the thing here. Now let us go ahead coding for the same. I'll explain you while coding only that how we are required to check for it test cases for the same. Basically, this is the question which is modification of two sum only. We have modified this the two sum solution into three sum solution. There we were having that adding up two numbers together to get a particular target, but here our target is 0 and not 0, but here our target is the third number itself. So that's the thing. Because see, if we add up two number and we are making it equal to the third number, right? So that simply means that whenever we right, this is these are let us take other thing. 1 plus 2 equals to 3, right? So these are the two numbers which is equal to this target. And now if it becomes something like this, then it will be equal to 0, right? So that's the thing which we are required to apply in this particular question. And that's the main idea behind this. So now let us go ahead with the implementation part for this thing. So here Okay. Now here we are given with this thing, means basically the output format of return type for this particular function is vector or vector int. So for that purpose, we are taking this, and then we are checking that if not checking, we are just directly taking in. This we are not required to check because in the constraint it is already given that at max, at a minimum, there would be 3 elements. Now first we are sorting our dumps, which is there, so that we are easily able to apply binary search or two pointers on the same. So that's why we are sorting. And because of sorting only, now it becomes login solution. And is that only a login solution. So now let us go ahead that what next we are required to do. So now we will be going up to n minus 2. So the last two elements we are here keeping for the j and k. Then first we are checking that I is equal to 0 starting. Okay. And nums of I is not equal to nums of I minus 1. Means either of these condition is there. This basically if I equal to 0, then only we will be checking for nums of I is not equal to nums of I minus 1. And then if that is a scenario, means both of them are not duplicates. See if it is equal to 0, right? Then it will become true and then it won't be checking this particular condition. And if it is not equal to 0, right, then it will be checking for this condition. So that's the thing here. And then here we are starting from left equals to I plus 1 because what we require is I, then I plus 1, and then means basically it should, if I is there that potential element, then it should start from I plus 1. So that's the thing here. So we are starting our left from I plus 1 and right is n minus 1. So that's the thing here. Now, while our left is less than right, means this is for the two pointer factorial, means that from the two sum question we have taken this. Its sum equals to nums of I, nums of left plus nums of right. Basically checking for the sum. If it is equal to 0, then surely we will be directly pushing this particular to our result vector. One minute. Then surely we are required to push all this into our result vector. So that's the thing here. But then next we will be checking that while our left is less than right, because there could be multiple solutions with just one element and other two elements would be different. So that the new triplet would be having new elements. So that's the thing. Means so now we are checking that while left is less than right, so that there is no overlap crossing of left and right. And then nums of left equals to nums of left plus 1, then we are incrementing left for avoiding the duplicates. Okay. And while left is less than right, again checking for the same condition, again avoiding the duplicates, then we are decrementing towards the right. And then we will be incrementing the left and decrementing the right pointer. This two steps which we have done just for the fact so that we can eradicate the duplicate parts, and then this thing was done. Now, if the thing is that sum is greater than 0, then surely we are required to move towards the forward direction. That's why we will be doing right minus minus, else we will be doing left plus plus. That simply means that sum is basically less than yeah, less than 0. So we are required to move towards the greater part. So that's the thing here. So basically the thing is that we are required to check for all the duplicates which are there. And then we are required to check that if these three triplet, which are, if this three numbers which form the triplet, does they even add up to 0, then it's good. But the next step which is required to be done is for eradicating the duplicates. We are doing the further steps and then incrementing and decrementing accordingly. And then if that was not equal to 0, then surely we are required to check for the other conditions and accordingly we are working in this particular solution. Basically, while doing all these things, we have boiled down our solution from what we say that. from n cube solution, now we have boiled down our solution to much more lower time complexity basically. So here, see, when it was a brute force, right? So at the time of brute force, by using three loop and for checking for non-duplicate triplets, we could directly insert that into a set, right? Thus, overall time complexity was n raised to power 3 log n. And n is the size of array and m is the size of set. And log m comes from the sorting of m elements using set. So we could use this. And just next variation to some problem means which I had already explained you earlier. So this is one of the best approach for doing the same. Here, because we are not using any extra space, the space complexity is directly of order of 1. And the time complexity now, let us calculate what exactly it is. 1 minute. Okay. So here, because of this fact, we are having time complexity equals to log n, basically n log n. And then here, it wanna be equal to order of n. Then we are having this while loop, right? It is order of n again, right? So if we check overall here, so the time complexity here is n log n plus n square. So overall time complexity, because n log n is much smaller, is smaller than n square, right? So that's why the whole time complexity here becomes order of n square, and the space complexity becomes order of 1. So this was all for this particular question. If you have any doubt, you can comment that down. And if you like the explanation, please do like and subscribe to my channel and also do share among your friends. So this was all. Thank you.